Okay, example number 7. Consider the voltaic cell. So we're given the cell notation, and it is found that the voltage is 0.963 volts when the copper ion concentration is 1 molar, and we're looking for the concentration of the bromide ion in the cathode half cell. So we're still looking for the bromide ion concentration, but we are now given the cell notation. So unsay reaction nga nahitabo sa anode? It is the oxidation of copper. So copper nga solid, 2Cu2 plus Aq plus 2 electrons. And then at the cathode, we have the reduction of bromine. So Br2, that's liquid, plus 2 electrons, producing 2 Br negative Aq. So what is the standard oxidation and the standard reduction? We look for them at the table. So for copper, the oxidation is negative 0.339 because we are going to reverse. And for bromine, so take note ha, 0.339 man siya diha. So balik taron, so negative 0.339. Ang sa bromine, it's 1.077. So 1.077 volts. So adding the two, we get the standard cell voltage. That's 1.077 minus 0.339. That gives us 0.738 volts. And we know that N is equal to 2. So for the Nernst equation, so E equals standard cell voltage minus 0.0257 divided by 2 ln of what is, so we're going to use the, we still have to write the final equation. So copper nga solid plus bromine nga liquid producing copper 2 plus Aq plus 2 Br negative Aq. So concentration ni copper times concentration ni bromide raised to the power of 2, and they're all divided by 1. Okay, solid or liquid naman ang nasa reactants. And then we substitute. So the cell voltage is 0.963 volts, and the standard cell voltage is 0.738 volts minus 0.0257 divided by 2. This is volts. Ln of the copper is given, it's 1 molar, and we are looking for the bromide ion concentration raised to the power of 2. And then, just like what we did with the previous examples, we transpose 0.0257 over 2 ln of the bromide ion concentration. That's 0.738 minus 0.963. So you subtract, kung pila ng 0.738 minus 0.963. That gives us an answer of negative 0.225. And then we cross multiply. Ln of Br negative squared equals negative 0.225 times 2 over 0.0257. And that gives us an answer of negative 4,500 over 257. And then we eliminate we convert to exponential form. So bromide squared equals e to the power of negative 4,500 over 257. So it's basically the same thing as what we did in the previous examples, and when we extract the square root. So the bromide ion concentration is equal to 1.5769 times 10 to the negative 4 molar. So this is the bromide ion concentration in the given voltaic cell. Okay, at this point we're looking for the pH instead of the just the concentration. So we are given the voltaic cell wherein there is the oxidation of the hydrogen in the anode and the reduction of iodine in the cathode. So anode, hydrogen, that's gas, 2H plus 2 electrons, that's oxidation is 0. And then at the cathode, so we have iodine. So we look for, let's try to see it. So it's solid form plus 2 electrons, 2I negative AQ. And the reduction, standard reduction of iodine is 0.534. Okay, so we're going to add the two equations directly. So we have hydrogen gas plus iodine solid. So we have 2H plus AQ plus 2I negative AQ. And the standard cell voltage is 0.534 volts, wherein N is equal to 2. And then we use the Nernst equation, so we directly, ato na lang i-direct substitute. So 0.841 volts equals 0.534 volts minus 0.0257 volts divided by 2 ln of. So still in this example, naatay solid, so di na to apilon. So the hydrogen ion concentration raised to the power of 2, iodide ion concentration raised to the power of 2 divided by the pressure of the hydrogen gas. Now, ang atong gipangita diri nga problem is the pH. So, and that, remember that pH is related to the hydrogen ion concentration. So meaning mangita sa ta sa hydrogen ion concentration, no? And by the way, so the iodide ion concentration is just equal to 1 and the pressure of the hydrogen gas is just equal to 1. So ang mahabilin basically diri kay ang H plus squared. So baliktaro na to, 0.0257 divided by 2 ln of the hydrogen ion concentration raised to the power of 2 is equal to 0.534 minus 0.841. So 0.534 minus 0.841 is negative, which is equal to negative 0.307. And then we cross multiply to get ln H plus quantity squared. So kani si 0.307 i-times 2 na to, i-divide of 0.0257. That would give us an answer of negative 6140 divided by 257. And then we eliminate the logarithmic na form. So that gives us e to the power of negative 6140 over 257. And then we solve for the hydrogen ion concentration by extracting the square root. So the hydrogen ion concentration, therefore, is 6.4882 times 10 to the negative 6 molar. So that's the hydrogen ion concentration. But we're not looking for that. We're looking for the pH. And pH is equal to negative log of H plus. And you just have to do not use the rounded off value. So I'm just writing the rounded off value, but I'll be using in my calculator the exact value. So you take the negative logarithm of the given answer, and that would give us a pH of 5.19. So there is no unit for pH, And when it says 5.19, meaning it is an acidic solution.